We're going to move, we're still in Chapter 1, but we're going to move into Section 3. And complex numbers, you've seen some things with complex numbers. We're going to actually be doing a significant amount of stuff that will involve complex numbers with the various equations we use and the various types. So you need to make certain that you are comfortable working with complex numbers, both starting from radicals and converting into the a plus bi form, as well as doing the add, subtract, multiply, and division of complex numbers. So we're going to look at a brief review of them. A complex number is just a number that contains this imaginary unit. Historically, it was established because mathematicians kept encountering situations where they would need to work with the square root of a negative number, and they needed a way to do that. If you, up to the point where you started complex numbers, if you encountered the square root of a negative number, you just said, I can't do anything. There's no answer. But because it is a fairly common occurrence, mathematicians decided to define this unit, I, lowercase I, to represent the square root of a negative 1. Using this, then you can take any negative number and factor it into minus 1 times a positive number. Separate the negative part out and be left just with the square root of a positive number, which you work with in a normal way. So this was done to overcome a mathematical situation. It turns out that it made a lot of science and engineering and technology and business and all kinds of other things. It allowed solutions to be found. And it is an extremely important part of working with any of those. So imaginary numbers, complex numbers are critical to working with higher level technical calculations. I is equal to the square root of minus 1. Therefore, I squared equals minus 1. Those are the two important quantities that you need to remember to work with complex numbers. In the book, they go into what's I cubed equal to, and I to the fourth, and I to the fifth, and so forth. And that's nice, but you don't encounter that often. Look at it to make sure you know what it's talking about. What it really boils down to is this is a cycle of 4. I squared is going to be equal to minus I, or I'm sorry, I cubed is equal to minus I, and I to the fourth is equal to 1. And then it starts over. I to the fifth is equal to this, I to the sixth, and it goes through a cycle of 4 where it just keeps repeating the same 4 values. But we're only going to really be interested in I and I squared. This is how it's used. If you have the square root of a negative number, you break that into the square root of the positive part multiplied times this quantity I. I is outside the radical. You're taking the minus part outside the radical. And what's left under the radical is a positive number, which you work with in a normal way. If you're going to work with complex numbers, the first thing you need to do is to put them into what's known as the a plus bi form. Real part plus a number times this letter I. All complex numbers can be put into that form. To do any kind of arithmetic on those, make certain you put them in that form first. Once you have them in that form, if you want to add or subtract, you would add or subtract the real parts, and you would add or subtract the imaginary parts. It's exactly the same as if you're combining like terms on a polynomial. Exactly. Absolutely no difference. You just treat the I as if it were a variable like x or y or z. So if you have this complex number and this complex number and you're adding them, you would add the a and the c, and you'd add the bi and the di. and we're actually going to we're going to factor out the I. That's a common factor of I, so we factor it out. If you're working with numbers, the B and D would just combine to give you a number. So let's add these two complex numbers. We're going to add the 4 and the negative 5 because those are like terms. We're going to add the minus 5i and the plus 8i. So 4 and minus 5 give minus 1, minus 5i and plus 8i give plus 3i. And that's the answer. Complex numbers have two parts, a real part, imaginary part. They will always have both. It might be, though, that one of them is 0. You could have just this complex number. That is a complex number. It has a real part and an imaginary part. It just happens that the real part's equal to 0. So it's still there, it's just you don't normally write it. You could also have this complex number. It just happens that its imaginary part is equal to 0. And you don't write the 0 part. So in effect, every number you've ever worked with is a complex number. It just had, those real numbers just have a 0 imaginary part. But they are complex numbers. All the rules that you worked with for adding, subtracting, multiplying, and dividing and everything else you could have applied the complex rules and you would have gotten the same answer. Subtraction, no difference. You just remember to apply your signs. Always have to follow signed arithmetic. So I take the parentheses off and I get that, then I combine the like terms and I get that. So adding and subtracting complex numbers, very simple. Multiplying complex numbers, it's like multiplying polynomials, term by term. Every term in this one times every term in that one. With a complex number, you'll only have 2 terms at most. You may have 1 or 2. And so you multiply them in the normal way you would a polynomial. Then, after you've done that, because you're multiplying complex numbers, you're going to get an I squared term. One term that has I squared in it, not more than one, just one. Where you had that I squared, you're going to substitute minus 1. So remember a couple of slides ago I said I equals square root of minus 1 and I squared equals minus 1? So instead of I squared, we're going to write minus 1. Then we're going to simplify what we can simplify. Here's one complex number multiplied times another complex number. Do the foiling of this. Normal cases, multiplying complex numbers is a FOIL type of operation. First times first, outside times outside, inside times inside, last times last. Give you 4 products, one of which will have I squared in it. Substitute minus 1 where that I squared is. Combine the 2 terms that have I in it. And then simplify. So that I get my real parts together and I get my imaginary parts together. Let's do it with numbers. It's a little clearer. We're going to multiply that. So I'm going to multiply first times first, outside times outside, inside times inside, last times last. Five times 2 is 10. 5 times minus 7i is minus 35i. 3i times 2 is 6i. 3i times minus 7i is minus 21i squared. Don't forget that square. You're multiplying I times I. It has to give you I squared. Only one term has I squared in it. These are not. If you don't wind up with any I squared terms, then you didn't do it correctly. You should get an I squared term, but only one. I can combine this one and this one. Those are like terms. Minus 35i plus 6i gives me minus 29i. I can substitute minus 1 in for I squared. So I do that. Then minus 21 and minus 1 give me plus 21. Add the 21 and the 10, and my answer. Any addition, subtraction, multiplication, or division of complex numbers should wind up with no more than 2 terms. May wind up with just 1 term, but no more than 2. You'll have a real part and you'll have an imaginary part. The answer will be a complex number. Multiplication, just FOIL together and substitute for I squared. Dividing complex numbers is a little more complicated. To divide complex numbers, you have to use what's called the conjugate of a complex number. Complex number has 2 parts, a real part and an imaginary part. That's the general form of a complex number. This is the real part, that's the imaginary part. The conjugate of a complex number is to change the sign of the imaginary part. So if I have that complex number, the conjugate of that complex number is that. I changed the sign of the imaginary part. I changed this sign. Similarly, I could, if I had this complex number, this would be its conjugate. I changed the sign of the imaginary part. In other words, they are conjugate of each other. They are a pair, a conjugate pair of complex numbers. And we'll use this idea of the conjugate pair when we start working with factors for polynomial equations later on. So it uses the conjugate. Now I know that I say uses the conjugate of the denominator because we're doing a division, and you can think of a division as a fraction, one divided by the other one, the divisor being the denominator. So what we're going to do is we're going to take the conjugate of that denominator, and we're going to multiply that conjugate times both the numerator and denominator. Let's look at what some conjugates would be. If you have a complex number 4 minus 8i, that's the conjugate. If you have 4 plus 8i, this is the conjugate. Minus 2 plus 3i. Notice I don't change the sign of the real part, just the imaginary part. So it's minus 2 minus 3i. If it's just the imaginary part, then you change the sign. If it's just the real part, then you're really not doing complex division. It's only complex division if that denominator has an imaginary part to it. If it's a real number in the bottom, don't worry about complex division. It's just normal division. What we're going to do is we're going to take the conjugate of this denominator, and we're going to multiply the numerator by that conjugate, and we're going to multiply the denominator by the conjugate. The reason we do that, multiplying a complex number by its conjugate produces a product which is only a real number, has no imaginary part to it. And so that gets our imaginary number out of the denominator. Once you've multiplied, you simplify. So let's look at an example. Here is a complex division. It's complex division because this has an I in the denominator. What's the conjugate of the denominator? Yeah, 3 minus I. Don't pay any attention to what the numerator is right now. We're looking at the denominator. We want the conjugate of that, and we change the sign on the imaginary part. So the conjugate is 3 minus I. Multiply both the numerator and denominator by that conjugate. If we do this multiplication, we're going to do a FOIL up in the numerator, we're going to do a FOIL in the denominator. If I make a mistake, somebody correct me before I get too far. Did I do my foiling properly? Four terms. FOIL gives you four terms, right? Now let's combine what we can combine. In the numerator, I can combine those two. In the denominator, I can combine those two. So in the numerator, I get 15 minus 5i minus 15i gives me minus 20i plus 5i squared. And in the denominator, what do I get? Those cancel, don't they? That's why we multiply by the conjugate, because those two middle terms will always cancel when you multiply a complex number times its conjugate. In other words, we're going to cancel out these terms that have I. And just left with the real number and I squared. But I squared, we can substitute minus 1 in there, right? Both places. Remember to always reduce your fractions to lowest terms. So our result only has two terms, a real part and an imaginary part. Several things you have to do. None of them are difficult. Multiply by the conjugate, simplify. Well, I should put in one. Multiply by the conjugate, substitute for I squared, simplify. So a little more to do than you do with multiplication, but not complicated things. Okay, now we didn't actually talk about this, but let's go through it. What if we start with the radical form? How do I convert this into a plus bi form? Now what I've got to do is I have to take this square root of a negative number. And the first step I always want to do when I'm working with something like that is to convert it. And if you remember, this can be broken into two pieces. This is the product rule for radicals. If you have two radicals with the same index, you can multiply them to get a single radical, or you can take a single radical and break it apart by its factors. So I broke this into the two factors, minus 1 and plus 5. Those are the factors of minus 5. There are only two sets of factors for minus 5. Plus 1 and minus 5, or minus 1 and plus 5. I picked minus 1 and plus 5. This part, that's equal to I. And then this is equal to the square root of 5. Over here, so that's equal to I and the square root of 15. At this point, you could simplify your radicals and then recombine and so forth. What I suggest is, At this point, go ahead and combine your two radicals and then simplify the single radical, rather than simplifying each and then recombining. So I say I have an I and an I, right? So I'm going to get an I squared. And I have a square root of 5 and a square root of 15, which means I can write that as one radical of 5 times 15. 5 times 15 is 75. Now let's simplify that. How can I simplify that? What's one thing I can do? Right, and why do you separate it that way? 25 is a perfect square. I can actually take the square root of that, can't I? And I know I'm doing this in many more steps than is really necessary to do, but it illustrates the different things that you have to do. You usually combine these together. And so I get I squared, square root of 3, and I get 5, right? Square root of 3, 3 is a prime, so I can't do anything more with it. Anything else I can do? What do I do with the I squared? -1. And actually, I've got a number here and a number here, so I would really write it this way. And you wouldn't take this many steps, probably. Don't make the mistake of saying, oh, square root times square root, that means multiply the -5 times the -15 and get square root of plus 75. That's going to give you the wrong answer. That's why I say your first step needs to be to take out the I. And so maybe your first step would be, I know I'm getting an I and an I, so I'll get an I squared, square root of 5 and square root of 15, and then on down. There are different ways to do it, but take the I's out first. Otherwise, instead of getting a negative, you'll wind up with a positive answer, which is the wrong number. Just be a single I, which has to be in the answer. If you're dividing, you're going to do a similar thing. So what would be the result here? What would you get for this division? Is this complex division? Or is it normal? Complex division means you need an imaginary part in the denominator. This is not going to have an imaginary denominator. It's going to have an imaginary part, it's just not going to be in the denominator. So this is going to be normal division in the way you'd normally do division. You don't have to worry about conjugate in this one. So remember that if you're multiplying radicals, if they have the same index, you can just multiply the two radicands together. If you're dividing them, you divide the two radicands. Anytime you begin with two radicals, I would suggest you combine them first, then simplify that result. Because in the first case, the first problem number 1, we really couldn't simplify these, either one of those. But when we combine them, there is a simplification that can happen. In this quotient, there is some simplification that can occur, but there's more simplification if you combine them first. But also, this is complex numbers, right? So your answer may or may not be a complex number. First one The radicals individually were complex, but multiplying them together gave you a real. This case, you may get a different situation. So what's the result of this? What do you get for an answer to this simplification, this calculation? I'm sorry? Well, I don't know. Let's see. I don't think so, but let's see. If we combine this, well, back up before you combine it. I said anytime you have the square root of a negative number, the very first thing you should do is take that negative sign out, right? And we have the square root of a negative number, don't we? So the very first thing you want to do is take that out. How would I take that out? What would it become? To take this out, we're going to pull this out and make it I times, well, before, I wish this thing would quit flipping around on me. I didn't touch anything and it went crazy. If we just pull that out, then it would be that. And I need to do that to, because I want, you need to make sure that you get that part of it. It's crucial that you do that. Now, after that, because we have two radicals, the next step would be to combine the two radicals into a single one. So you'd have the I. If you combine these, you get that. Simplify the fraction. What do you get when you simplify that fraction? And then you would simplify the radical. This one won't simplify, so that's your final answer, is I times the square root of 2. Take that negative sign out as your first step. Don't do anything before you do that. Then, if you're still left with two radicals, combine the radicals. Simplify what's underneath the radical, then simplify the radical. If you still have a fraction, you'd break it back apart into two separate radicals, one in the numerator, one in the denominator, to simplify it. In this case, the fraction just became a whole number, and then you'd simplify that single radical, which in this case doesn't simplify. So, step by step. All right, that's just converting. Now, what if you want to add complex numbers? What would this result be? Remember that adding and subtracting complex numbers is just combining like terms. Come on, what would this be? Yeah, this should be simple stuff. You should have been doing this for years. Combining like terms. This should not be a complicated thing to do. And if you're working on some other work, perhaps maybe you should do that some other time. Okay, what if you're multiplying? You will see some complex numbers in this course. You need to be able to work with them. If you didn't get that as a first step, then you did it wrong. You need to get all four of these. Yes. Not sure. We'll have to get there to see. Here we can combine like terms and also substitute for the -1, or substitute for the I squared. Then I can combine this and this, so -8 and +6, unless I made an arithmetic error, that should be what you get. So it is pure FOIL. Substitute for the I squared, combine like terms. That's all you have to do to multiply complex numbers. FOIL, substitute for I squared, combine like terms. -2 + 16.